Okay guys, this is our first video from lesson 7.6, or 7, excuse me, chapter 7, lesson 6. There we go. I'm going to try my best this time not to sound sad, as I was told in the last video I sounded. So right now turn to page 558 in your textbook and we'll go ahead and begin today's lesson. Now today we're talking about solving addition, subtraction, inequalities. At least we are in this first video. And there are some rules here. These rules you actually do know already, believe it or not. But you're going to see them more in action when we do these examples. Basically, all the rules that we have up here on the screen are telling us is that whenever you have an inequality, if you add something to one side, you have to add it to the other side. And same thing with subtraction. If you have an inequality like you do here, if you subtract something from one side, you have to do it to the other side in order to keep it balanced. That's all it's telling us. And we will definitely demo some of this in this first example. So let's go ahead and look at example 1. Now what I'm going to go ahead and do here now is clear out some space so I can do some work. So we go ahead and kind of just make the wrong thing I wanted to use. Here we go. I'll start there. All right. So here we have our little blank space, and let's go ahead and start looking at the problem. It says solve each inequality. To remind you, an inequality is anything that has a symbol like this, a less than or greater than symbol, or less than equal to or greater than equal to symbol. Represent the solution set on the number line provided. So here we have an inequality, excuse me. The inequality is a plus 1/2 is less than 2. So as always, our first step should be to rewrite the inequality all over again so we have enough room to actually move things around. A plus 1/2 is less than the number 2. We want to know what this mystery number A is right here. In order to do that, we have to follow a simple process. First, we identify our variable. Our variable is the letter A. Then we have to figure out what's happening to it. Well, A is being added by the fraction 1/2. Well, what will we have to do to that 1/2 to get this letter A all by itself? We're going to do the inverse of adding 1/2, which is subtracting 1/2. So I'm going to go ahead and subtract 1/2 from the left-hand side of my inequality. And whatever I do on the left-hand side of this symbol, I have to do to whatever's on the right-hand side. So from over here, I'll also subtract 1/2. Now I'll continue to work out my inequality. Notice there's nothing underneath the letter A, so it just goes ahead and falls right on down. So we have A. Here I had plus 1/2, take away 1/2. Well, that equals 0. I don't need to put a 0 here because adding a 0 does not change anything at all, so I'll leave it blank. Adding a half, excuse me, let me get rid of that menu. Adding and subtracting the same number always leads to 0. Now, my symbol comes right on down, and I go ahead and do the math I have over here. 2 minus a half, well, that's equal to 1/2. Now, here's what's new. We have to explain and understand what this solution we have here means. Well, that means that my letter A for this equation here, or the one we have here, can be any number as long as it's smaller than 1/2. So let's show that on a number line. I'll draw a generic number line here. Here's 0, here's positive 1, here's positive 2, here's negative 1, here's negative 2, and of course we do know the numbers go on in both directions forever. So we want to graph this solution. A can be any number smaller than or less than 1/2. So here's 1/2. 1/2 would be right here. I'm going to go ahead and draw an open circle because that means we're starting here at 1/2, but the point 1/2 itself is not one of our answers. Our answers are anything smaller or less than 1/2. Now let me kind of show you on the side what's really happening there with a little check. So let's say we pick any number that is smaller than 1/2. Like let's try the number 0. All right, so we have the equation 0 plus 1/2 is less than 2. If I substitute 0 in there for the letter A, and I add 0 plus 1/2 is less than 2, we do the math. 0 plus 1/2 is just 1/2. Is 1/2 less than 2? Yes, that's true. So that means that's a good solution. Now, what if you pick the number 1/2 itself? What if you think that's an answer? Well, if I take my original equation, which is A plus 1/2 is less than 2, and I plugged in 1.5, I would have 1.5 plus a half is less than 2. 1.5 plus a half is 2. 2 is not less than 2. 2 is equal to 2. So this would not be a true statement, which means the answer 1.5 that I used here would not work. So what's happening here is that any answer I want to plug in for A has to be smaller but not equal to 1.5. And I can pick any number I want that is smaller than 1.5. I can go from here all the way down to negative infinity. And every number I can pick that's on this line will always make this statement true. That might be a bit to wrap your head around at first, but it will make more sense as we go on. Now, on the side of your notes, you have something that's very important. Here it says open and closed dot, and you're going to notice that when we graph, sometimes we have graphs where we have a dark dot and it goes in a certain direction, or sometimes you can see we have an open dot and it goes also in a certain direction, and you want to know what the difference is. When graphing inequalities, an open dot is used when the value should not be included in the solution, as with greater than and less than equalities. So the one we just did was an example of that. The 1.5 we used is a starting point, but it's not part of the answer. Excuse me. Now it says a closed dot indicates the value is included in the solution, as with less than, greater than, and equal to or greater than inequalities. These ones which are new, you will experience in the next example. So let's go ahead and just move on. If you have any questions about this first example, please make a note somewhere on the side over here where you have space for notes. And be very specific about your question if you happen to have any. If not, then just go ahead and follow along with me to the next example. So I'll go ahead and clear this out, and we'll go ahead and scroll on down. Here the book just talks about what we said in example 1. So scrolling down to example 2. Whoops, there we go. And once again, just to make some space, make it a little easier to read and see, I'll go ahead and clear out some space here. All right, I like to use a lot of space, just like you would on your separate sheet of paper. No reason why you can't spread everything out. So let's go ahead and get right on this. First step is always to look at our equation or inequality. In this case, we have this inequality. Negative 6 is greater than or equal to some mystery number n minus 5. Always begin by rewriting your algebra equation or inequality. So we have negative 6 greater than or equal to n minus 5. Okay, so the first step is to identify our variable. Our variable is the letter n. What is happening to this letter n? Well, it is being subtracted by 5. What will undo, or what is the opposite or inverse of subtracting by 5? Well, the opposite would be to add by 5. So I'm going to go ahead and add 5 over here on the right-hand side. But we learned it above on the page above that if we add something to one side of my inequality, I have to add that same amount to the other side to keep it balanced. So now I'll go ahead and work up and down from left to right. I have negative 6 plus 5. If I'm at negative 6 and I go positive 5 steps, I end up at negative 1. My symbol will just come on down for now. The n has nothing happening underneath it, so the n will go ahead and just drop on down. If I had minus 5 and then I had plus 5, that equals 0, so that cancels out. Now I have this solution. N is less than or equal to negative 1. So n can be any number smaller than or equal to negative 1. So to graph that, I will first need to make a number line. All right, now I know n has to be less than or equal to negative 1. That means I can have a closed dot because negative 1 is one of my answers. It can be equal to negative 1 or it can be less than. So n is less than negative 1. That means everything over here. Because remember with negative numbers, the more negative direction you go, the smaller they really are. So all these numbers, any number along this line into a negative infinity, will always make this and this inequality true. To prove it, let's pick a number. Let's try right here, negative 3. Negative 3 is on the line, it's right there. So let's take my equation. It was negative 6 is greater than or equal to some mystery number minus 5. I'm going to pick the mystery number of negative 3. So I want to see if it works. Negative 6 is greater than or equal to negative 3 minus 5. Well, I'll do this math. If I'm at negative 3 and I go minus, which means left, 5 steps, I end up at negative 8. And as with all negative numbers, the bigger they look, the smaller they really are. So negative 6 is greater than negative 8. So that is a true statement, which means everything on this line, like I suspected, is also a solution. You can pick any number, whole number, decimal, fraction. As long as it's found on this line, it'll always make this inequality true. Now, what if you pick something bigger? My favorite number to always use is 0. 0 is not on my line, so let's see what happens if I use that. I would have negative 6 is greater than or equal to n minus 5. If I said n was 0, I would get 0 minus 5. 0 minus 5 is negative 5. Is negative 5 less than or equal to negative 6? No, that's false. Negative 5 would be about right here. Negative 6 would be over here. Negative 5, since it's to the right, is bigger than negative 6. So negative 5 is greater. This symbol does not say that here, so I know this whole statement is false. Therefore, I know numbers over here would not work, because all these numbers would make this original inequality not true. Now, what you need to go ahead and do now is write down any specific questions you want myself or Mr. Andrade to address over here on the side. Whatever your questions are, write them very specifically over here, if you happen to have any. If you think you're following along and understanding very well, then let's go ahead and go on to the next step, which is to go ahead and work on these Goddard problems that we have right here. Oops, I don't need to move the page like that too much, but that's not a big deal. So we have these Goddard problems right here. You need to go ahead and work on A and B, and make sure you make a number line. 0 does not always have to be in the middle. It usually is, but sometimes you can, maybe if you have a lot of negatives you're dealing with, maybe you want 0 over here. Or if you have a lot of positives you're dealing with, maybe you want 0 over here. So think before you start graphing anything on these lines, because you can't really go back and redo these, especially if you're writing in pen or marker. So good luck with this, and I'll see you in the next video.